Are you ready, Michał? Rock and roll.
Yes. I'm ready, but this is hard. Really, because I have a bad news for you. Ruby. Ruby. Ruby is dying. Well, wait. I don't actually agree with that. Yeah, some people said that Ruby is dying and Ruby is no more, Ruby is something, and yeah, I have actually quite opposite opinion. That Ruby right now, whoa, is more alive than ever. You got a spoiler there. Remember JavaScript? I mean, a couple of years ago, we had this point in time when our computers got better, our browsers got actually usable, and some people extracted JavaScript engines outside of the browsers and started using them in a different ways. Some of them were crazy, like Backbone. It opened the way to this client-side applications. Some were even more crazy, like Node.js, which allowed JavaScript to go into servers. I wouldn't allow JavaScript on my server, that's for sure. But some other people did something that really blew our mind, like created Meteor. Yeah, there were some valid cases, and people also did some really interesting stuff, like this one, Milestone. Commodore 64 emulator in JavaScript. That's something. Linux running on JavaScript. Wow. Quake-free? Come on. That's really something really good. And what we could do about that, we could only envy those guys. I mean, yeah, okay, they need to program in JavaScript, so that's kind of fair. But on the other hand, the JavaScript was ubiquitous, and they could use it on server side, on browser side. And there were some ideas on using the same code base in the different applications. But now we have the technology. We have Opal RB, which is pretty interesting stuff. This is the Ruby to JavaScript compiler. Anybody heard about that? How many of you have used it in some serious way? Okay, cool. Fair enough, that's one person, that's great. So basically, if you don't know it, it's Ruby to JavaScript compiler. Basically does same thing as CoffeeScript, but does it better because it compiles Ruby into JavaScript. It's quite performant. A bit worse than CoffeeScript, but still. It's not version 1.0, so I wouldn't recommend it to everyone. But yeah, people do some interesting stuff in that. Some people do some Backbone-like frameworks. Some people do Meteor-like frameworks. And I think that this is something that we could use. And it's actually really simple to use in Rails. You just do Rails, new, and you just specify Opal Rails, and it will work. So you would be able to write your JavaScript in Ruby. That's pretty awesome. There is also a RubyMotion, which is kind of better version of MacRuby. Unfortunately, it's paid, but you can do a lot of interesting stuff. So basically, it's a static Ruby compiler. So it compiles Ruby to Objective-C runtime. So have anyone used RubyMotion? Cool. You should try it out. If you have $300 to spare and want to make applications for iOS and OS X, go for it. It's really, really great. And it's stable right now, actively developed, and widely used in production. So I think that's something that we should use a bit more. And also, mRuby was released a couple of weeks ago. So at least version 1.0. And I won't talk too much about Ruby because mRuby because I don't know that much about it. But I know that basically you can embed virtual Ruby machine inside of any C program. So that's promising. So maybe finally someone will be able to write a Commodore 64 compiler in Ruby. I would love that. Okay, so that's fine and dandy, but are all those things really a Ruby? Well, there has to be some drawbacks. And basically, yes, there are differences. For example, in RubyMotion, there is no require at runtime, no eval at runtime. You still can do metaprogramming, for example, with a define method and providing a block. But if you need to parse a Ruby source code, that's impossible. Basically, Apple won't allow that, and it's disabled. You could have some problems with method with multiple arguments. That's because Objective-C uses a different syntax for those methods. And those methods will have different names. So you will see a method that will take one argument and a hash, but it will not be not that method. It will be actually a method with named arguments. So you could have some problems if you want to send method names to objects that run on RubyMotion, but it's not that bad. The other thing that is pro, but might cause problems, is that threads are working concurrently. So if you were writing some code using threads in MRI, you might have a bad time. And memory leaks are possible in RubyMotion. So this is kind of interesting because there is no garbage collector. There is a reference counting for cleaning up our mess. And we could create cycles in dependency of the objects, and that could cause problems. So it's not that bad, but you also need to be aware of that. Okay, when it comes to Opal, there is static require only, because it doesn't make sense to require files in the browser. And all the requires that we do in Opal are translated into directives of sprockets. And also there are some things that needed to be done in order to make Opal performant. So strings are immutable, symbols are strings, numbers are floats, JavaScript. And it's incomplete. So most of the stuff is done, but for example, you cannot have a for loop. You can use each method, but nobody implemented for loop in parser. Yes, but is it that bad? They are different. They are not entirely Ruby. But the good thing is that they are Ruby enough. And what excited me the most in this JavaScript revolution that happened some time ago is that I saw the possibility of reusing some part of code in application that was running on multiple platforms. And I think right now, using this subset of the Ruby, we can do that. And let's call it cross-platform Ruby. And if you see that picture, it should remind you something. Anybody has an idea? Okay. Yes, hexagonal architecture. So let's think about that like in hexagonal architecture or ports and adapters. So think about that your whole application becomes an adapter, and your domain of the application lies inside of this cross-platform Ruby, and this can be reused on all different platforms. But that's not actually feasible. So I cannot imagine somebody to wrap the whole application in an adapter. That's pretty ridiculous. So this image should look basically like that. It's a bit more complicated, but bear with me. It's not that bad. So the idea is that to encapsulate parts of the domain logic of our application and either get something out of it or drive the rest of the application from it. So let's talk about interesting things, which are usually boundaries. So what are those interactions? And let's take a look at them. First, internal interactions. So what happens when we have this subsystem in cross-platform Ruby talking to another subsystem in a cross-platform Ruby? How to implement that? Well, that's an actually cool problem to have, because we can use clean architecture, hexagonal architecture, DCI. What was that? Command query separation. Exactly. You can use micro libraries, which I actually think that will fit quite well here. Domain-driven development, functional programming, even cowboy coding. Well, you can use anything here because this is your dreamland. This thing can be written in plain Ruby objects. All interactions might be separated, and you can use mocks, you can use stubs, you can use mutants, you can use anything you want here and code it as you want it always to code applications. This is your dreamland. But what about the other interactions? Let's start from simple ones. For example, access from outside. So think about this application in iOS and application in Rails needs some resources or needs to tell the core domain of something. So in the first case, the example would be some kind of translator subsystem that would provide basically the same labels, same resources for application in iOS and application in Rails. And it's basically like that. So create a class, create a getter, and you have it. And access from outside can be also giving an order to the core domain. For example, let's say we want to know what user did in our application. So the user flow is different on different platforms, but the interface for the mechanism that store our events of the user can be the same. So we can provide a same interface and use it in both platforms. Okay, what about the interaction going from inside to the outside application? So this is the case when when we talk about domain-driven development, this is probably something that we have in mind. So the core, the heart of the application can tell the adapters what to do. So let's say we have an image editor application and we want it to behave exactly the same in the browser and on desktop. So we need to create some kind of abstraction on each platform to, for example, encapsulate animations, like in this case. And once we have that, we can use this thing from inside of the application, and it will work exactly the same on each platform. Okay, but there are some a bit more complex interactions. For example, when the outside world needs to talk to the heart of our application, and also at some point, maybe asynchronously, maybe not, the inside of the application needs to somehow interact with the outside world. So let's take this simplistic example and think how can we do that. So basically, it's a part of the domain logic for a to-do application. We have to-do item, and it has method mark as done, and it's basically is a setter for the done flag. And that's all. That's our plain old Ruby objects that does the stuff in the domain. And let's say we do that, but after after marking the to-do as done, we want to save it. And the save on different applications might be something different. For example, save in a browser might be consist of sending the data to some kind of API. And save in a Rails might be just saving it to the database. And let's say it needs to happen asynchronously or needs to happen at some point, at some other point in time. Maybe we mark to-do item as done, it does something else, and something else even later on needs to interact with our application. So how we could do that? And in many different ways, but let's talk about three ideas, like having an abstract interface, notifications, and aspect-oriented programming. For example, abstract interface requires us to change our domain class to know something about the outside world. So in this case, we have some kind of saver object that can save a to-do item. And we can inject it to our to-do class and use it after the mark as done method. So in this case, we needed to change the mark as done method, which might be good, might not be good, depending on what you want to do. And on the other side, you just basically, for example, you could create this saver and compose it with a database adapter on Rails, maybe compose it with a Rails adapter on iOS, and the rest of the code would look the same. Yeah, so this have a pro that has well-defined interaction. So we have the interface, we know how to deal with that, but the core needs to know about the external use cases. And sometimes domain logic doesn't need to know that the to-do item is saved. It's just maybe something external. But this thing is useful when the use cases on each platforms are similar or even identical. For example, saving basically is the same on each platform. But let's say we don't want to know what happens with the to-do item after doing some action. So we could, for example, use some kind of notification system, which would be events or maybe data binding or maybe key value observation or whatever you want, but I call it notifications. So in this case, we could, for example, include some kind of eventable module to our to-do application, and again, modify mark as done method. But right now, mark as done method doesn't need to know about a specific case of saving the to-do, but it knows that somebody might be interested in that action. So that's kind of a good thing here. And basically, on the side of the browser or on the side of the iOS, we could just listen to that event and give it a block and save it to database or post it to API or do whatever we think we should do. And yes, so basically core doesn't need to know about specific interactions, but core do need to know that some kind of interaction might happen. So for every interesting action, we need to provide a trigger that will send the notification. Okay, so I would use that, for example, when use cases on each platform are a bit different. But beware here for memory leaks, because it's really easy to create cycles in dependencies in RubyMotion, and yeah, you will have a bad time basically. Okay, aspect-oriented programming is pretty interesting thing. Basically, it's also the callback, but callback given from the different direction. We could, for example, need a use case that we don't want to change sorry, our to-do class at all. So our to-do class just do the domain logic. It marks to-do item as done, and that's all. So how do we save objects in a use case like that? Basically, on the iOS side or Rails side, we need to use some kind of aspect-oriented library. There are some. And we need to inject our callback from the outside to react on this method. And this is also valid use case sometimes. I would use it very rarely, but and the reason is that while it gives you total freedom when to react on some things, it also forces the adapter to know exactly what is happening inside of the domain. So domain is not anymore a black box with a public interface. In this case, we need to know exactly what method happened and apply the callback at a specific point. And also beware of memory leaks here. Okay, so how to... that was kind of hand-waving, but... I'm sorry for that. That was kind of hand-waving, but how to actually start doing that? Well, basically, find out what is the common code base of your application that you could extract, and extract it to a gem. But there are things that you need to be aware of, that gems on different platforms needs to be set up differently. For example, when you include the gem that you want to use in Opal, in a main file of the gem, you need to let the Opal library know. So basically, when you run bundle, so this thing runs on MRI, it takes the Opal library and needs to add the path for the files in the gem. After that, in your assets file, when you write your JavaScript in Ruby, how awesome is that? Then you can just require those things, and they will be translated into Sprockets directives. If you want to create a RubyMotion gem, so then you have this problem that RubyMotion doesn't allow requires at all. And you need to set up the project in a way that all files from the gem that you want to use need to be included in the configuration file. And basically, you can do it like that. So if you run a rake task on RubyMotion, it runs on MRI. It figures out it is in RubyMotion project, and it just opens it and adds files to be compiled. And after that, you can use all those things exactly as you would require them. If you want to start doing that, I would have some suggestions. So basically, create one folder for your application. Create a couple of different applications, so Rails application, iOS application. Rename them to iOS Rails for convenience. Extract these common patterns into gems. Put them into the same folder, just to because you will be skipping around those files like crazy, and it's a really good thing to have it in one place, but keep them in different directories. If you work in teams, use semantic versioning. It's really important. But if you work alone, yeah, you can skip it. And replace rules with better ones if you find them. Is it for everyone? No, of course not. So let me give you an example. I work at Base in Krakow, and we have this product that makes thousands of people happy every day at work, and they pay us a lot of money. And we really don't want to screw things up. And so basically, if at some point in time Apple decides to screw RubyMotion and do not allow the applications, then we would be screwed. So that's one of the reasons we don't use RubyMotion. But the other is that we already have the applications on multiple platforms, and we already have a group of talented developers for each of them. So for us, it's not really a case. But we do use some things. We do extract some functionality in gems when it's feasible. For example, configuration of each of our services in a service-oriented architecture. But yeah, so we would not be able to go cross-platform Ruby. But I think this is a valid use case for some people. For example, imagine that you want to create a game prototype, multiplayer game prototype, and you want it to run on multiple platforms. So that's really a good use case because you can extract all the game logic into a separate gem, use it in your applications, and be happy with that. So does it work? Well, it does. I wanted to prove it to you by telling you at first that I've created a sophisticated economical simulation and then show you a cookie clicker clone. But I have something better because this is a serious conference. So I basically created a tic-tac-toe application. Let me find it. Okay. And what do we have here? So this is basically an iPhone emulator. And you can start a game here. You can join a game here. Well, I haven't implemented automatic reloading, but yeah, it's your turn. Then we reload it here. It's your turn. Okay, I'm not very good at that. That's a pretty complicated game. Okay, oh shit. Okay, once more. Yay, yay, I've won. And I lost. Okay. So this application is interesting because it's, well, not actually only a tic-tac-toe game. It's basically a platform for creating multiplayer board games. And once I'm done with that, it will be really easy to add a new game. For example, well, do you have, oh, chess, for example. And in order to change the game, I would need to, on each platform that has a client, I would need to create a view for the board itself. The rest will not change at all. And change a couple of classes, I think 3 or 4 of them, inside of the domain logic. So the thing on the left is running Opal, and it actually includes all the classes from the domain logic, and the same with iOS. So, and also they communicate through a Rails application that also uses the same classes from domain logic. So, do we have 5 minutes of time? Okay. So I can show you some source code. I hope it will be interesting, at least. Where is my cursor? Okay. Yeah, this will be, oh, maybe I'll do mirroring. Okay. Okay. So what I can show you. Okay, let's start with the directory. So you can see that I have iOS application, I have Rails application, and I have my gem called turn-based. And inside of this gem, there is this whole engine for the game. There is a specific classes for tic-tac-toe game, and there are some things called interactors. I'll get back to that a bit later, but basically those things are really simple. So move is a plain Ruby object that can save and load it save to a hash or an array or something that can be converted to JSON. And there is also a board game that knows how to knows all the rules of the game. Yeah, it's not that interesting to talk about that, but interesting thing are the interactors, and this is something I don't think it's ideal solution, but it worked in my case. So I wanted to abstract the communication of the game logic and the backend. So, for example, I wanted to make a move, which would mean that first I need to, on the local client, I need to validate if this move is correct. If it is correct, then I send it through to my Rails application. It receives the data. It also needs to check if the move is correct. Then save it to database. Then send the response back. And the response need to be also well, response doesn't need to be validated. Response doesn't need to be validated on a client. and that's basically how they communicate. But what I found that in my specific case, the saving was exactly the same as from the client point of view. Saving was exactly the same as sending them through to API. So I've created the class interactor that is used in every possible place. So it takes always objects from domain logic, and it always returns objects from domain logic. So for example, when we take a look at what makeMove does, it just takes game, takes player, takes column, takes row, and it tells game to build the move object for the player, makes the move, so it's still part of domain logic, and it calls an adapter that makes a move and gives him some information about that. So at this point, when we call an adapter, we know that our domain logic already validated everything that was there, and our objects at this point in time are valid objects, and we can save them or send them. And how to use those things? So basically, let's start with the Rails controller. API, games. Okay, so makeMove looks like that. We have the game interactor that has an event on move made that is triggered from the interactor. And when the move is made, we right now know that everything is okay, and we can send the result to the client. And here we set it up. So first, from the active record objects, we take out the domain objects, pass them to the interactor, and it does the work. And this part works exactly, works basically the same like on the client, but the thing that is different is the database adapter. So basically this method is called when we make move, and it just basically finds the database player, it finds the database game, it updates the domain logic game, it serializes it to the database, and it actually triggers the move made interactor. And for example, in assets, JavaScript, whoa, where are my JavaScripts? It's only Ruby here. Cool. I have an adapter that is REST adapter. And when it receives make move, it basically makes the HTTP request and sends the move to our Rails API application. So basically, all of those things interact through this one class and adapters, and it required a bit work up front. But once I got that on one platform, it was really simple to have the same implement same features, same use cases in different platforms. So that basically proves that it works. That's I won't tell you that you should use that in production, but if you want to try, if I manage to interest you in that, you can go to crossplatformruby.com, give me your email, and I'll let you know when I have some interesting, more interesting stuff to say about that. And I would also like to hear your ideas how to basically move that forward. Maybe I'm totally wrong about that, and I also would love to hear that. All in all, I think that Ruby is alive, and it's taking over the world. One platform at a time.
Thanks, Michał.
Thanks.
Any questions?
If you don't want to use sprockets for some reason or another, is there any way you can still use Opal?
Sure. For example, basically Opal works on multiple different platforms. Like it works on Node.js, and right now you cannot require files in Node.js, but I think it will be possible in future. So if you just use require, it would translate to the Node.js thing, import or something like that.
Okay, thanks.
Any other questions?
You mentioned that some code is shared between the server side and the Opal side. I would be a little bit worried that somebody might read into the JavaScript code and figure out how my server side works and find some vector to attack me. Did you think about that? Is that a concern?
Yeah, that is valid point. So I think you need to think about what do you want to publish, because like everything you put into JavaScript is readable for everyone, even if you obfuscate that. So I think that is a valid point to a valid reason to use multiple smaller gems inside of your application, and maybe include the one gem that can be safely published, but keep the rest for the server side. And maybe you can use it in, for example, iOS application as well for saving to database, for example, in the same way. So you don't need to reuse everything on every platform. Just take a subset that you want to share between some of the systems.
Hey, and don't you think that people try to over-engineer the solution on front end, where it's different from backend, because on backend you many times need to worry about many users, many games, and things are way more complicated than on the front end, when you probably have one user and one game at the time, and the design could be way more simpler.
Yes, I think so. Like in my case, I designed it this way because I want in the future to add the functionality to allow people to play the same game with a computer. And basically, I would need to provide only an algorithm for the computer to play, but the rest of the code will stay the same. But yeah, in like different applications, it's probably a better idea to keep saving to database in like one way and like sending to API in another, but maybe reuse that part of code. I don't know, like it depends.
Any more questions? Okay, then thank you very much, Michał.
Thank you.